All right, you're welcome back, guys. Let's look at directional derivative, right? Let's look at directional derivative. Now we have this question with us here. Find the directional derivative of this function. Okay, we just talked about this kind of functions now that depend on multiple variables, right? It could depend on x and y. It could be depend on x, y, and z, right? Now we have this multiple function. This function that depends on multiple variable, x and y in this case, x squared plus xy, right? Now we're asked to find the directional derivative of this function in the direction of a unit vector u, right? Now the vector u is I plus 2j, right? In the direction of this vector here, I plus 2j. Okay, let's spice up the question and add at a given point. Let's say at the point 1, 1 at the point where x is 1 and y is also 1, right? So let's solve this question. Find the directional derivative of f of x and y equal to x squared xy in the direction of u equal to I plus 2j at the point 1, 1, right? Now what do you do? What do you do if you come across this kind of question? This is what you do. Listen up. Now the solution we're going to have for this is this. We're going to follow this procedure. The directional derivative of this function f, right, in the direction of u, the unit vector u, is simply the gradient of the function f, which we just finished doing in the previous video, right? I believe you've watched. Okay, the gradient of this function here multiplied by, okay, this dot product, okay, dot product, the unit vector u and its magnitude, right? This the vector u and this is the magnitude of u, right? This is the unit vector. Okay, so we're going to find this and then this, then multiply both of them using dot product. Okay, find the dot product of both of them. Okay, so let's see, how do we find the gradient of the function? Now the gradient of this function simply is, if you don't know, the partial differential of this function. What's the function again? This is the function, right? Of the function, let's just say of the function f with respect to x, and the partial differential of that same function with respect to y, right? So this is going to be, let's differentiate this function with respect to x. Differentiate x squared with respect to x, that's going to be 2x, right? Right. Then you differentiate this same function with respect to y. What's it going to be? Now if you differentiate this one here, this first term, we're working with the whole function here. You differentiate this first term here with respect to y, is going to be 0, right? Differentiate this one with respect to y, is going to be x. Okay, let's show working for that, for those of you who don't understand. Now if you differentiate x squared, this is x squared, right? We're trying to differentiate this function now with respect to y. We did that with respect to x. Okay, we're not even done with respect to x. Wow. Differentiate this function with respect to x. For the first term, you get 2x, right? That's correct. How about the second term with respect to x? That's going to be y, right? Right? Right. Then you differentiate with respect to y. My bad, I skipped that part. Okay, let's differentiate this now with respect to y. Differentiating this first term with respect to y is going to give us 0 because it does not have any y attached to it, right? So I'm going to introduce y at y raised by 0. Now there is a y there, but it has power of 0, right? It doesn't even exist. It's not there. It's just there as 1, right? So let's differentiate this with respect to y. Since we differentiate with respect to y, this term, every other term is going to be a constant, right? So you multiply the power of y with the constant, it becomes 0. Then you reduce the power of y by 1, which is still going to end up giving us 0, right? So differentiating this first term, this function with respect to 0, with respect to y rather, for the first term, it gives us 0, right? Then differentiating the next term with respect to y, again, is going to give us x. You understand? Okay, so the gradient of this function is going to be 3x plus y, right? Okay, there's no need for the bracket, but this is it. We found this, right? You understand how we found this? You differentiate it partially with x and y. Now let's find the unit vector of u. That's like the next step. Okay, what's the vector u? Like what's the vector u? What's vector u? Now that's I plus 2j, right? That's u. Okay, since it's a vector, it should have this small arrow, tiny arrow sign on top. Okay, this is u. What's the magnitude of u? That's going to be the square root of the I component squared. Now this is 1. How many I do we have? We have 1 of it there. So it's going to be 1 squared. Then the square of the j component as well. And we have just 2 of it. So it's going to be 2 squared. Okay. So the unit vector is going to be I plus 2j over the square root of, okay, this is 1, this is 4. That's like square root of 5. Amount of space. This is going to be I plus 2j over square root of 5. I'm still out of space, but I'm going to split this into two parts, right? Just splitting there. This is going to be, okay, I'm going to leave it that way since I don't have space by this side. So we found the unit vector. We've also found the, what's this called? Okay, we found the unit vector, we found the gradient of the function. So we're going to just, find the scalar product or the dot product of both of them, right? This first one here is 3x plus y, right? 3x plus y multiplied by, what's this? We have, okay, I'm going to split this the way I wanted to. That's going to be 1 over square root of 5i, right? Plus, this is going to be 2 over square root of 5. 2 over square root of 5 as the j component. That's the splitting I'm going to do here, but there was no space. Alright, so we now have the I component and the j component, right? 1 over square root of 5 and 2 over square root of 5. Alright, so let's find the dot scalar product of these two. I'm going to multiply the x component with the I component, right? So this is going to be 3x times this. That's 3x times 1. That's just 3x, right? Over the square root of 5. Then I'm going to multiply the y component with the coefficient of the j component, right? The j component. Now that's going to be 2y. 2y over the square root of 5. Now normally this should be the answer before we added this other part of the question at the point 1 and 1. This should be the answer. This is the directional derivative of the function f in the direction of, okay, this is the, what's it called, directional derivative of the function f in the direction of u. Okay, this is it. But since we have spiced up the question and added a point, you can see the points, right? 1 and 1. That's where x is 1 and where y is also 1. So I'm going to substitute those values. Directional derivative at this point is going to be 3 over square root of 5 plus 2 over the square root of 5. Now this is x, right? I'm going to substitute x as 1 and substitute y as 1 as well. Okay, so this is going to be 3 over the square root of, you can see that, right? Square root of 5 plus 2 over the square root of 5, which you can just add up to give you the square root of 5, right? Square root of 5, 3 plus 2, that's 5. This is going to be the answer at this point. Directional derivative of this function at the points 1 and 1 is 5 over root 5. Okay, let's take an example, and that will be it for directional derivative. We move on to next part of this calculus. Alright, so for the second example, I'm going to replace this paper. Let's place it properly. Alright, this is the second example. And this function now has, okay, this function depends on three variables, right? X, Y, and Z. We are asked to find the directional derivative of this function in the direction of this unit vector. Okay, maybe we're still going to edit this out and add, a point. Okay, a specific point. We're going to specify a point. But first, let's just make sure that you guys understand this. Okay, let's see. The solution, what's going to be the solution of this? What's going to be the solution? Now, the directional derivative of the function, okay, is tf, right? In the direction of v, this unit vector v, this vector here v, directional derivative of v of f rather in direction of v is going to be the gradient of the function, right? Then having a scalar product, we're going to find the scalar product of the gradient of this function with the unit vector of v, right? That's v over its magnitude. Okay, so all we have to do is find the gradient of this function and then this, and we find the product, scalar product, right? So what's the gradient going to be? What's the gradient of this function going to be? Remember, we're going to differentiate the function with respect, okay, partially with respect to x, then differentiate that same function partially with respect to, okay, with respect to y, and it has z in it, right? X, y, z. So we're still going to differentiate again partially with respect to z. Okay, so pay attention as we go through this partial differentiation, right? There's video on partial differentiation. You can go back and watch it to understand better, right? We actually differentiated this partially. All right, so what's the gradient function going to be? Let's differentiate this function with respect to x, right? This function here, right there, with respect to x. So that you can spot the x there, x squared, right? So 2 and z going to be a constant, right? We're going to multiply this constant with 2, going to become 4, right? 4z. Then we reduce the power of x by 1. You remember, right? So this is going to be 4z x. Now x has reduced from 2, the power of x has reduced from 2 to 1, right? We use that 2 to multiply 2 and it became 4, right? And I'm just going to arrange this alphabetically. Thank God my pen is erasable. I'm going to arrange this alphabetically as x, z, right? Since x comes before z. Alright, now that's the partial differentiation of the function with respect to x. Okay, we still have other terms to differentiate. I've made that mistake again. Let's differentiate the second term still with respect to x, right? You can spot the x right there. So the other terms, the other numbers, the other letters, they become constants, right? They become constants. So I'm going to multiply the power of x with these constants. That's 1 currently. It is 1. So I'm going to multiply this with 1. And it's still going to remain the way it is, since it's 1 we're multiplying with 4yz squared, right? Why didn't I write my x? Oh no, why didn't I write my x? Because the power of x there is 1. You reduce it by 1, it becomes 0. X is gone, right? So this is the partial derivative of this function with respect to x, right? Now let's find let's find the partial derivative of this same function with respect to y. Hope you can see everything. Alright, let's find the partial derivative of this function with respect to just y, right? Now, there is no y here. What happens? It becomes 0. Since the power of y there is currently 0, the differential of this with respect to y is going to be 0, right? So, do I have to write 0 here? No. Let's differentiate this next term with respect to y again. There is y there. You can spot the y there, right? And it has the power of 1 currently. So I'm going to multiply the constants. You know, every other letter becomes a constant. I'm going to multiply the constants with the power of 1, right? So it becomes 4x z squared. I multiply them now, it's 1. What happens to our y? We reduce the power of y by 1, it becomes 0. So y is going to be eliminated, right? So this is just going to be the partial differential of this function with respect to y. Now let's look at the partial differential of this function with respect to z. Okay, what is it going to be with respect to z? There is z here, so we're going to differentiate this with respect to z. What is it going to be? It's going to be 2x squared. There will be no z because the power of z is going to become 0 after differentiating, right? Now let's differentiate this next term again with respect to z. What's going to be? Now z in this case, this z in this case has the power of 2, right? So I'm going to multiply 2 with the constants. Every other letter becomes a constant. Multiply this with 2, right? So that 4 right there becomes 8. That x and that y stays there, and the power of z reduces by 1. So from 2 is going to become just raised by 1, right? So this is the partial differential of this function with respect to x, y, and z, and that will be 8. Let's find this unit vector. Alright, so what's the vector v? What's the vector v? As I, j, minus 2k. What's this magnitude of v? That's 1 square, right? Plus 1 square again. Then this is negative 2 square, though it's not going to even matter, right? Alright, so this is going to be ij negative 2k over the square root of 4, 5, 6, square root of 6, right? And I'm going to do that splitting this time around to avoid confusion. There is one I here, there is one j here, there is negative 2k. So it's going to be 1 over square root of 6i, right? 1 over square root of 6i plus, we're going to have 1 again, 1 over square root of 6j, alright? Then negative 2k, that's going to be negative, this time around, negative 2 over square root of 6k, right? So this is going to be what it looks like, right? This, and this. So I've gotten the two terms. Now all I have to do is find the scalar product of both of them scalar product, right? So I'm going to multiply this is this, multiply this with this, multiply this with this, right? Like we did in the previous, where is it? Remember, we multiplied this, just this with just this, right? Let's do the same here. What's it going to be? Okay, directional derivative of the function f in direction of v is going to be, I'm just going to write everything out so you don't get confused. This is 4x z plus 4yz square. That's the first one. Then this is 4xz squared. That's the second one. And this is 2x squared plus 8xyz. That's the third one. We're going to find the scalar product of this with, okay, let me just make use of the square bracket since it's what we're using here. 1 over square root of 6i, that's this, right? Then 1 over square root of 6j, that's this, right? Negative 2 over square root of 6k, that's this. So what's the directional derivative going to be? I'm going to multiply this with this, this with this, and this with this. Understandable now, right? Okay, so 1 over 6, sorry, 1 over square root of 6 is going to be multiplying this guy here. So that's going to be 4xz plus 4yz squared, right? Then this is also going to multiply. We also have 1 over 6 for the j component, right? It's going to multiply this. So 1 over square root of 6, rather, square root of 6, not just 6. It's going to be multiplying 4xz squared. You understand? Finally, we're going to have negative, because it's negative here, right? Negative 2 over square root of 6 is going to be multiplying this guy. That's 2x squared plus 8xyz, right? This should be our answer. You can simplify further if you want, but to end this video, we're just going to edit the question a bit at the point, in case it comes out this way in your test or exam, whatever you're preparing for. Right, at the point, you can pick any point of your choice. Let's just say 1, 2, 3. I'm just going to say 1, 1, 2, so the video doesn't take time. 1, 1, 2, easy numbers, right? 1 over square root of 6, and this is going to be 4 times what's x? X is going to be 1, right? 1, 1, 2. I'm trying to edit the question now. Don't get confused. The directional derivative of the function at 1, 1, 2. You can use 1, 2, 3. You can use 4, 5, 6. You can even use negative numbers, right? But what you have to do is, this is x, y, and z. X, y, and z, right? X, y, z. The value of x at this point is 1. The value of y at this point is 1. The value of z at this point is 2. So wherever I see x, y, and z, just do the needful substitution and you get your final answer, right? So this is x, x is 1. This is z. Z is 2, right? Plus, what's this? 4. This is y, happens to be 1. This is z, happens to be 2 squared, right? That's for the first one. Now let's look at the second one. Plus 1 over square root of 6. Then we have 4 multiplying x happens to be 1. Z happens to be 2 squared. 2 squared, right? Z happens to be 2. Alright, then finally we're going to have negative 2 over the square root of 6, and this is 2. X happens to be 1, right? 1 squared, that's going to be 1, plus 8. What's x? 1. What's y? 1. What's z? 2. You understand, right? Alright, so just use your calculator and punch in the needful, get your final answer. I'll see you in the next video. Alright, take care, bye. Do it to subscribe, of course. I'll see you in the next video. Let's talk about color vectors and what's the other guy called? I'll see you in the next video.